So the next example, we're going to have to work backwards. It says the area of two similar pyramids is 36 and 81. So the ratio of the areas is 36 to 81. That represents, because it's area, that represents a squared to b squared. To find the ratio of the perimeters, we want a to b. So we have to figure out what a is, and we have to figure out what b is. Well, if a squared is 36, then a would be the square root of 36, and b would be the square root of 81. The square root of 36 is 6, and the square root of 81 is going to be 9. And then of course I want to check to see if this reduces. 6 divided by 9, math, enter, enter. And that gives me a fraction of 2/3, which represents my a to b. So the ratio of the perimeters a to b is 2 to 3. Alright, so now we can use the ratios to solve for either missing sides or missing areas or missing volumes. So for this example, it says two similar polygons have a scale factor of 7 to 5. Well, this is their scale factor. Remember, scale factor is a to b. So my a to my b is 7 over 5. The area of the large polygon is 147. So the large polygon would correspond to the larger length, which is 7. So that's going to be 147 on the top. We want the area of the smaller polygon, so we'll put x on the denominator. We can't just set these equal to each other and cross multiply and solve the proportion because we don't have them in common terms. Area is a comparison of a squared to b squared. So we can't compare the scale factor a to b to area. We have to get this a to b to be a squared to b squared before we can set up a proportion. So let's square a and b, which gives us 49 over 25. And now that we have, this is a squared and this is b squared, we can substitute the values in here and then cross multiply. So a squared we found to be 7 squared, which is 49. And b squared we found to be 25. So now we have the area a squared to b squared equals to a squared to b squared. We have common terms. So we are going to cross multiply. We get 49x equals 25 times 147. And that gives us 3,675. And then I'm going to divide by 49 to find out what the area of my smaller figure is. So I get x is 75. So the area of the smaller polygon is 75. Alright, so why don't you give number 10 a shot? We have the ratio of the perimeters is 3 to 5, so that's a to b. We want the scale factor and the ratio of the areas. Pause the video and see if you get what I get. Alright, number 11, they give you the ratio of the areas. So remember, the ratio of areas is a squared to b squared. To get the scale factor, you need it to be a to b. And the ratio of the perimeters is also a to b. So in this example, you're going to have to solve for a and b. Pause the video and see if you get what I get. If you're having trouble with this, please let me know or ask a neighbor. The next example, the ratio of the areas. Once again, areas is a comparison of a squared to b squared. The scale factor is a comparison of a to b, and so is the perimeter. So pause the video and let's see if you get what I get. And for this one, if you didn't give the reduced fraction, your answer is considered incorrect. So it's not going to be 4 to 6, it's going to be the reduced fraction 2 to 3, and so will the ratio of the perimeters. Two circles have a radii of 5 and 7. Radiuses or radii are original side lengths. Their comparison would be a to b. So the ratio of the areas would be a squared to b squared. So you would get 25 to 49. Okay, so number 14, you have the radii again, 8 to 12, which is a to b. The ratio of the circumferences we also refer to as a to b, because that's just a ratio of perimeters, and perimeters is a to b. The ratio of areas is a squared to b squared. So pause the video to see if you get what I get. Now for this example, if you didn't reduce the fraction, then your answer is considered incorrect. So you should have had 2 to 3, and then the ratio of the areas would have been 4 to 9. Alright, number 15, you have the ratio, or the areas of two circles. So you have 144 and 64. To make a comparison of the areas of two circles is taking a squared to b squared. To find the ratio of the circumferences, you have to solve for a and b. So you will have to work backwards on this one. Pause the video and see if you get what I get. So the ratio of the circumferences should be 3 to 2. Number 16, you're going to need to draw a picture of two triangles ABC and DEF. Then to find the ratio of the perimeters and find the ratio of the areas. Pause the video and see if you get what I get. Okay, number 17, the ratio, we want to find the ratio of the perimeters of the small figure to the large figure. So first we have to match a set of side lengths. So if we match 7 with 21, the ratio would be 1 to 3 once we reduce. And the ratio of the side lengths is a to b. So the ratio of the perimeters would also be a to b, which is 1 to 3. And for the last example, I'd like for you to find the area of the smaller polygon. They're giving you the scale factor a to b. So when you solve for the missing area, you want your comparison to be a squared to b squared in order to figure out the area for the smaller polygon. Alright, pause the video and see if you get what I get. Alright, you should have gotten the area of the smaller polygon to be 45. If you didn't, raise your hand or ask a neighbor.